Ever pondered about the possibility of skipping through time or teleporting across the universe? These are not just whimsical musings of a curious mind. They are the fascinating questions that have enthralled scientists, philosophers, and dreamers across generations. In the vast, seemingly limitless expanse of the cosmos, the concepts of wormholes and time travel have long tickled our collective curiosity. These are not merely the stuff of science fiction, but are grounded in the complex and intriguing world of theoretical physics. At the heart of these theories lies the concept of spacetime, an integral part of Einstein's theory of general relativity. Einstein proposed that the universe is not just three-dimensional, but is a four-dimensional fabric, woven together with the threads of space and time. This fabric can be warped and bent by the gravitational pull of massive objects, creating what we perceive as gravity. Now imagine if this fabric could be folded, bringing two distant points in space and time tantalizingly close. This is the concept of a wormhole, a theoretical shortcut through space-time. Similarly, if we could move along this fabric at different speeds or directions, we might be able to travel through time. These notions, while fascinating, are fraught with paradoxes and uncertainties. They challenge our understanding of causality, the idea that cause precedes effect. They question our perception of reality and the linear progression of time. Yet they also open up a world of possibilities. Could we one day harness the power of wormholes for interstellar travel? Could we peer into the past or future through a time machine? These are the questions that fuel our exploration and innovation. As we probe the depths of the universe and the intricacies of physics, we are continually pushing the boundaries of our knowledge. And in this quest, we may find answers not just about the universe, but also about our place within it. So join us as we embark on this exciting journey. Let's delve into the theories that seek to unravel these enigmatic phenomena. Have you heard of Einstein-Rosen Bridges? These are no ordinary bridges, but theoretical passageways through the fabric of space-time. Coined after Albert Einstein and Nathan Rosen, the term refers to a concept more commonly known as wormholes. Wormholes are fascinating because they propose a shortcut through space-time. Picture this: you're at point A and you want to get to point B. In a three-dimensional universe, you'd have to travel the distance between them, right? But what if you could fold the universe so that point A and point B touch? That's what a wormhole might do. So, how do they work? Well, it's all based on the theory of general relativity. This theory suggests that mass and energy warp space-time, creating curves. Wormholes could be these curves connecting two different points in space-time. Imagine being able to step into another universe just like walking through a door. Did you know that quantum entanglement could be the key to understanding wormholes? Let's delve into the theory that connects these two fascinating concepts. Imagine two particles entangled in a way that the state of one instantly affects the state of the other, no matter the distance between them. Now picture a wormhole, a hypothetical shortcut through space-time. Some physicists suggest that these entangled particles could create a sort of quantum wormhole, linking disparate points in space or even time. This idea combines the weirdness of quantum mechanics with the grandeur of general relativity, forming a bridge, if you will, between the incredibly small and the immensely large. It's a mind-bending proposition, but it could bring us closer to a unified theory of everything, one that reconciles the quantum and the cosmic. In the quantum realm, things are truly stranger than fiction, and as we continue our exploration, you'll see just how strange things can get. Could black holes be our ticket to the past or future? Let's delve into this mind-bending concept, shall we? Black holes, these enigmatic cosmic phenomena, are regions in space where gravity pulls so much that even light cannot escape. Now imagine if we could harness this extreme gravitational pull for time travel. The idea is based on the notion that black holes could potentially warp space-time fabric. Picture a massive cosmic trampoline, and a black hole is like a bowling ball in the middle, causing a deep dent. This dent or warp could theoretically create shortcuts or wormholes through space-time. However, it's not as simple as hopping into a spaceship and zooming off into a black hole. The tidal forces, or difference in gravity's pull, could stretch you into a long, thin strand, a process whimsically termed spaghettification. But let's not get discouraged. Science is full of surprises, and who knows what the future holds. Hold on tight, because a trip through a black hole would indeed be a wild ride. What if you could go back in time and prevent your own existence? Now that's a thought-provoking question that brings us to the grandfather paradox. This paradox is a classic conundrum in time travel theory, and it goes something like this. Imagine you've invented a time machine and you decide to travel back in time to meet your grandfather before he has any children. But then what if you accidentally prevent him from meeting your grandmother? If they never meet, one of your parents would never be born, and consequently neither would you. But then, if you were never born, how could you have traveled back in time to prevent your own birth? It's a loop that seems impossible to resolve. This paradox highlights the complexities and potential inconsistencies of time travel. It's a reminder that time travel isn't just about ticking clocks, it's also about ticking paradoxes. Ever thought of time as a ball of yarn? It's a handy metaphor to grasp the theory of cosmic strings and loops. Born out of the Big Bang, cosmic strings are predicted to be thinner than an atom, yet incredibly dense. Imagine them as near-invisible threads stretching across the universe with the gravitational pull to bend time and space. Now let's introduce loops. When two cosmic strings cross paths, they can form a loop. Picture a loop in our ball of yarn. These loops could theoretically create a shortcut through spacetime, a sort of cosmic detour that could allow for time travel. But don't pack your bags just yet. Scientists are still trying to confirm the existence of these elusive strings and loops. And even if they do, navigating them would be a feat beyond our current technological reach. Unraveling the mysteries of time might just require some cosmic knitting. Is it possible to change the past without creating a paradox? This question leads us to the Novikov self-consistency principle, a fascinating theory about time travel. Named after the Russian physicist Igor Dmitrievich Novikov, this principle suggests that the past is unchangeable, and any action a time traveler might take has already been accounted for in the course of history. Imagine you're a time traveler. According to the Novikov self-consistency principle, everything you do in the past would already be a part of the historical timeline. So if you were to go back in time and try to change something, you'd find that you couldn't. Why? Because whatever you were attempting to change had already happened, and your actions were already part of that event. In essence, this principle eliminates the possibility of creating time paradoxes. It paints a picture of the universe where everything is self-consistent and where time travel might not be as simple as cause and effect. What if every decision you've ever made created a new universe? This mind-bending question introduces the concept of the multiverse, a theory that suggests the existence of countless universes, each with its own laws of physics, dimensions, and timelines. Picture it like this. Each choice, each random quantum event spawns a different universe. So when you decided to wear that red shirt instead of the blue one this morning, you didn't just choose, you created a whole new universe. How does this tie into our exploration of time travel? Well, the multiverse could potentially solve those pesky time travel paradoxes. If we travel back in time and change something, we aren't altering our original timeline. Instead, we're spawning a new universe with its own unique timeline. So don't worry about accidentally erasing yourself from existence. In the multiverse, every choice, every chance, every change is not a mistake or a risk, but a new adventure. In the multiverse, every choice is a new adventure. Could the key to time travel be hiding in the smallest places? Welcome to the world of quantum foam, a concept as intriguing as its name suggests. Quantum foam is a term that describes the turbulent nature of space at extremely small scales. Picture a frothy sea, but instead of water, it's made up of space and time. This theory, born from quantum mechanics, postulates that the fabric of the universe is not smooth, but rather a bubbling brew of virtual particles constantly popping in and out of existence. These particles could, theoretically, form tiny, temporary wormholes. Imagine for a moment dipping into this foam and emerging in a different time or place, all thanks to these microscopic wormholes. While it's purely theoretical at this point, it's a tantalizing thought, isn't it? The idea that the universe's smallest structures could hold the secret to traversing its vast expanse. So remember, time travel might just be a matter of looking closely enough. What if you could send a message to your past self? This is where the concept of the Tachyonic Antitelephone comes into play. It's a theoretical device that exploits the odd properties of tachyons, hypothetical particles that are thought to move faster than light. According to special relativity, such particles would have the remarkable ability to travel backward in time. So how does the tachyonic antitelephone work? Well, imagine sending a message using these tachyons. Due to their faster-than-light speed, the message would arrive before it was even sent. This, of course, raises some mind-bending questions about causality. If you could send a message to your past self, could you change the course of your history? Or would the universe somehow prevent any paradoxes from occurring? Theoretical physicists are still grappling with these questions, but one thing's for sure. Who needs a time machine when you have a tachyonic antitelephone? Is time just an illusion? It's a question that has puzzled philosophers and scientists alike for centuries. The mystery has only deepened with the introduction of the theory of the arrow of time. This concept, rooted in the field of thermodynamics, suggests that time might only move in one direction due to the increase in entropy. Entropy, in the simplest terms, is the measure of disorder in a system. According to the second law of thermodynamics, the total entropy of an isolated system can never decrease over time. It's this principle that dictates the arrow of time, propelling us forward into a future of increasing disorder. But what if we could manipulate entropy? Would that allow us to reverse the arrow of time, to travel back to the past? These are just conjectures, of course. The truth may be far more complex and elusive, but one thing remains certain. Perhaps the real secret to time travel is understanding the nature of time itself. So what does the future hold for wormholes and time travel? Delving into the future of these concepts, we see a tapestry of possibilities, each more fascinating than the last. From the enigmatic nature of Einstein-Rosen Bridges to the mind-bending implications of quantum entanglement, our understanding of wormholes and time travel is expanding at an unprecedented rate. Einstein-Rosen Bridges, or wormholes, as we've discussed, are theoretical passages through space-time that could create shortcuts for long-distance travel across the universe. The future of this theory could see us harnessing these shortcuts, making interstellar travel a reality rather than a concept confined to the pages of science fiction. Quantum entanglement, on the other hand, suggests that two particles can be linked in such a way that the state of one instantly influences the other, no matter the distance between them. This principle could open doors to instantaneous communication across vast cosmic distances, or even time. Theories about time travel through black holes, cosmic strings and loops, and the tachyonic antitelephone all hint at the potential for journeys not just across space, but also through time. The future here could see us exploring the past and future, witnessing history firsthand, or catching a glimpse of what's to come. However, with time travel comes the risk of paradoxes, such as the infamous grandfather paradox, but theories like the Novikov self-consistency principle suggest that any actions taken by a time traveler would already be part of history, thereby preserving causality and avoiding any paradoxes. The concept of a multiverse and the quantum foam theory could redefine our understanding of reality itself, suggesting that our universe is just one among many, or that space-time at its most fundamental level is a seething mass of quantum fluctuations. So as we move forward, the potential for future technologies and research in wormhole and time travel theories is vast and exciting. The reality of these concepts might be far off or just around the corner. Who knows, maybe one day we'll be able to take a weekend trip to another era or universe. Until then, keep dreaming and keep exploring. As we journey through the vast cosmos of quantum physics and cosmic theories, it's your curiosity and thirst for knowledge that fuels our exploration. If you've learned something new or found this journey through time and space intriguing, give this video a like and share your thoughts in the comments. Are there other topics you'd like us to delve into? Let us know. Don't forget to subscribe and hit the bell icon to be notified of our future expeditions into the unknown. And remember, the future of wormholes and time travel isn't just in the hands of scientists and researchers, it's also in the minds of the curious, the dreamers, and the explorers. So why not share this video with your friends and family and inspire them to join us on this journey? Until next time, keep dreaming, keep exploring, and who knows, one day we might just meet in another era or universe.